In this particular example, we've been asked to find the derivative of the function y equals the cosine of x, which is all raised to the exponent x. This is not an algebraic function, it is not an exponential function, and it is not a trigonometric function, but we can find its derivative. We use a similar approach that we used in the previous example. We start by logging both sides of the equation, in this case using logs with a base of e, or natural logs, and that's how we obtain our second line. The natural log of y equals the natural log of the cosine of x, all raised to the x. To get the third line, what I've done is used one of my laws of logs, so that I obtain the natural log of y equals x times the natural log of cosine of x. What I'm now going to do is differentiate both sides of the equation with respect to x. Now, if my left-hand side of my equation had read the natural log of x, its derivative would simply be 1 divided by x. But it reads the natural log of y. So when I take its derivative with respect to x, I must use implicit differentiation, and I obtain 1 divided by y prime. On the right-hand side of the equation, I have one function, x, being multiplied by another function, the natural log of the cosine of x. So I have to use the product rule. Well, in the next line what you see is x, that's my f of x, being multiplied by the derivative of the natural log of cosine of x. And that derivative is found by using the chain rule, and I obtain 1 divided by the cosine of x times negative sine x. I add to that my g of x, which in this case is the natural log of cosine of x, times f prime of x. Well, the derivative of x is simply 1. In my next line, all I've done is clean things up a little. So I end up with 1 divided by y prime, equals negative x sine x divided by cosine x, plus the natural log of cosine of x. Remember that I'm trying to solve for y prime. So to do so, I must multiply both sides of the equation by y. So I end up with y prime equaling, in the squared brackets, negative x tangent x. The tangent x is just using our quotient identity that sine x divided by cosine x is tangent x. Add to that the natural log of the cosine of x, and then that's all multiplied by y. If you remember, our original function is y equals the cosine of x raised to the x. So I can substitute cosine of x all raised to the x in for y, and that's how I end up with my final derivative, which is expressed solely in terms of x. So y prime is equal to negative x tangent x plus the natural log of cosine of x, and that is all multiplied by the cosine of x raised to the x.